So the main question for this lesson is, which one do I pick? How do I know if it's linear? How do I know if it's quadratic? How do I know if it's exponential? I have to figure it out. So until now, we have been told which regression line to use. Now you have to decide which one best fits your data. So first, if you have a table of value, you want to examine the first difference, second difference, and the ratio. So you have to do all three of them. Now if you find the first difference is constant, stop. You don't have to do anything else. Okay? If you found that your second difference is constant, stop. But if you did not, then you have to go to the ratio. Then after that, you can create a scatter plot on Excel, and then you can look at your R-squared value. Okay? Remember that the closer the R-squared value is to 1, the better the fit. So what you're going to do, you're going to do the same graph 3 times, and then you're going to do 3 different regression lines. Okay? You're going to do linear, you're going to do quadratic, and you're going to do exponential. And the one that gives you the best R-squared value, so the closest to 1, then this would be your best fit. Okay? So here, you don't have too many options, right? Either you do the table of value, or you graph on Excel and find your regression line. Okay? So let's look at this. I have electrical appliances, a VCR, digital clock, contain a capacitor of power during brief electrical outages. The table shows how the voltage in a capacitor decreases over time after a power outage. Which type of relationship seems to exist between voltage and time? Justify your answer. So I have a table of value. I can literally take this and plug it in and do my exponential, or I'm going to do the first, second, and the ratio. Okay? We can do both to make sure that both of them are they give you the same answer. So let's do the first difference first. As I said, don't copy these down, just because I have to move fast. So if I do 7 minus 9, I get negative 2. 5.2 minus 7, I get negative 1.8. This one, I get negative 1.3. Negative 0.9. Negative 0.7. If you look at this, what do you see?
It's not constant.
It's not constant, so it's not linear, right? Because if the first difference is constant, that means it's linear. So I have to move to my second difference, right? So second difference, remember that with a second difference, you have to use your first difference, right? So you have to go negative 1.8 minus negative 2, right? So that gives me positive 0.2. Then you have to do this minus this. You get 0.5, 0.4, and 0.2. What do you guys notice?
Not constant.
Not constant, so it's not quadratic. Okay? So it must be then,
Exponential.
then it could be exponential. Remember that if neither of them are constant, then it's neither linear nor quadratic nor exponential, right? Most likely it's going to be one of them, right? Because we're talking about them.
In this case, it's exponential, right? Because the one
We have to check.
Okay.
We have to do the ratio and check. When you're doing the ratio, you're going back to your table. You forget about your first and second difference. You're going back to your original table. You're going to divide 7 by 9. Zero 0.7 what? So that's 0.8. Okay? This is where it's important to know how to round. If I do 5.2 divided by 7, I get 0.8. Right?
Oh, yes.
Yes.
If I do 3.9 over 5.2, I get 0.8. If it's not 0.8, it's 0.79 or 0.78 or 0.77, right? So it rounds to 0.8.
So 5.2 divided by 7 is 0.74.
Okay, so 7.4.
Pause.
So what do you notice? It's as constant as it's going to get. Okay? When you're dealing with like real actual points, you're not gonna be 100%. And remember, I'm trying to find the line that best fit. It doesn't have to fit 100%. It's a best fit. So what we can say here that it's almost constant.
Yeah, it's not 100%, 0.8.
Right? This is almost constant, so we can say that it is exponential.
What if we have two answers same, but the rest are not same?
Like, how different are they? That's the question.
Okay.
Right? If this is 0.8 and then 0.8 and then you're going 1, 2, 1.5, then it's not. Right? Now, this is using the first difference, second difference separation. I can also graph these, and I can show you the r squared. The important part right here is to look at the r squared. So let's do that one quickly. I don't want you to do anything. I just want you to look at my screen. So 0, 2, 4, 6. Okay. So if I pick that regression line, and I'm going to start with linear, okay? And then r squared. My r squared value here is 0.96, okay? Now, I'm going to pick polynomial with a degree of 2. It's 0.997. So that's even better. I'm going to pick exponential.
0.99.
So it looks like here it's the quadratic is a better fit. You see that? But in my table of value, it looks like exponential is a better fit. Did I have all my points correctly? 0, 2, 4, 6, 8, 10. Let me go back here. 9, 7, 5.2, 3.9, 3, and 2.3. Yep. So if I look at my graph, it looks like, using my graph, it looks like this is the better fit. Sorry, not the exponential, the quadratic. But doing my table of value, it tells me that my exponential is a better fit. Now, this is a very close call, so there's no way I can tell you if you're right or wrong. But if I'm looking for my table of value, I can tell you right away that this is not constant, so you can't use that. Okay? You have to stick with the exponential. Now let's take a look at another question, for example. Okay? So this question wants you to use Excel to select a model. Okay? So in this experiment, students purchased a hole, punched a hole near the bottom of a 2-liter pop bottle. They filled the bottle with water and measured how the water level changed over time. The results are shown in the table below. So they started with 30 centimeters of water, and then after 25 seconds, after 50 seconds, 75 seconds, and 100 seconds, what happened to the measurement of water in the bottle. So use a graphing technology to perform linear, quadratic, and exponential regression on the data. So let's go to Excel and let's see what's going to happen here. So 0, 25, whoops. Okay. So if you're looking at this, what can you guys tell me? What does it look like?
Exponential.
Does it look like exponential?
Yeah.
Let's see. So if I do my regression line, and I start with linear and I go with the r squared. My r squared is 0.9778. Okay?
Should be close to 1.
It should be as close to 1 as possible. Polynomial,
1.
1.
1.
100%.
100%.
Okay.
This is exponential. So which one is a better fit? Quadratic, right? So basically, you picked which one it is.
Yeah.
The closest to one, the closest to one, the better. Okay, so you must go with quadratic here. Okay, so let's write down what we have found. This might be a little off because I have used a different, I've used a graphic calculator instead of Excel, so it might be a little bit off, but it won't be violent. You know what? Let me do this instead. Then it will be better. So this is the quadratic. I'm going to do this.
This is here.
No, this
Mhm.
This is here.
Yeah.
Yeah. Okay, and if I pick linear, you see that's exactly what I've had. But remember that in this case, I don't have my axis title. You guys have to have axis title, so make sure that when you do that, you will put the axis titles. And exponential. That actually was very close. That's a very close call here. But remember, when you're writing the equation for the exponential, you have to write the proper equation, not the one with the e. Right?
Yes.
Okay. Now, one is which model best represents the data? So I'm gonna say that the linear is the worst fit because it was 97, right? %.